Imagine looking up at the night sky and knowing that somewhere out there exists a star so enormous that if it replaced our sun, it would swallow most of the solar system. Not just Mercury, not just Venus, but Earth, Mars, and possibly even the orbit of Jupiter. It sounds impossible. A star so large that entire planetary systems could fit inside it. Yet the universe is filled with objects far more extreme than anything we experience on Earth. Astronomers have discovered stars so enormous that measuring them becomes incredibly difficult. Their surfaces stretch billions of kilometers into space, and their outer layers are barely held together by gravity. These stars are known as hypergiants, the true monsters of the cosmos. But how can a star grow that large? What forces allow it to expand to such unimaginable scales? And if one of these stellar giants suddenly appeared in the center of our solar system, what would actually happen to Earth? To answer that question, we need to explore the largest stars ever discovered and the strange physics that allows them to exist. Let's start with the star we know best, the Sun. From our perspective on Earth, the Sun feels enormous. It dominates our sky and provides the energy that makes life possible. Its diameter is about 1.39 million kilometers. That means more than 1 million Earths could fit inside it. To us, that scale already seems almost impossible to imagine. But in the vast universe, the Sun is considered a fairly ordinary star. There are stars that are 10 times larger, 100 times larger, even 1,000 times larger. The reason is that stars change dramatically over time. During the early part of their lives, stars like the Sun remain relatively stable. They fuse hydrogen into helium deep inside their cores, producing energy that pushes outward against the crushing force of gravity. But eventually, that balance begins to change. As stars age, the fuel inside their cores slowly runs out. When this happens, the core begins to contract under gravity. And as it shrinks, the outer layers of the star expand outward. The star grows larger, much larger. In fact, stars can expand to hundreds of times their original size. These swollen stars are known as red giants. But even red giants are not the largest stars in the universe, because some stars begin their lives far more massive than the Sun. And when those giants reach the later stages of their lives, they expand into something even more extreme. Massive stars live fast and die young. They burn through their nuclear fuel much more quickly than smaller stars like the Sun. But before they reach the end of their lives, something dramatic happens. Their outer layers begin to expand to incredible sizes. These stars become supergiants. One of the most famous examples is Betelgeuse. Betelgeuse is one of the brightest stars in the night sky and forms the shoulder of the constellation Orion. But its true scale is difficult to imagine. If Betelgeuse replaced the Sun at the center of our solar system, its surface would stretch past the orbit of Mars. Mercury would be gone. Venus would disappear. Earth would be inside the star's outer atmosphere. Even Mars might not escape its fiery reach. The surface of Betelgeuse is not solid like the surface of a planet. Instead, it's a turbulent ocean of plasma. Massive convection cells, each larger than entire planets, slowly rise and fall across the star's surface. And Betelgeuse is not even the largest star astronomers know. There are stars even bigger than this. Stars so large that their outer layers extend across distances that would swallow much of our solar system. One of the most famous giant stars ever discovered is Scuti. Located about 9,500 light-years from Earth, Scuti is one of the largest stars ever measured. Its radius is estimated to be about 1,700 times larger than the Sun. To understand how enormous that is, imagine placing Scuti in the center of our solar system. The star's surface would stretch beyond the orbit of Mars, then beyond the asteroid belt, and eventually it would reach the orbit of Jupiter. Every planet from Mercury to Jupiter would exist inside the star. Earth would not simply be heated, it would be completely destroyed. The oceans would boil away, the atmosphere would evaporate, and the planet itself would likely be torn apart by the star's intense heat and radiation. Yet even Uy might not hold the title of the largest star, because astronomers have discovered another candidate that may be even larger. A star known as Stephenson 2-18 may be the largest known star in the entire Milky Way. Stephenson 2-18 lies inside a massive cluster of stars thousands of light years away. Its estimated radius may be close to 2,000 times the radius of the Sun. If this estimate is correct, the star would stretch across nearly 10 billion kilometers. Placed in our solar system, its surface could extend beyond the orbit of Saturn. Entire planetary systems could fit inside this star. But stars like Stephenson 2-18 are incredibly unstable. Their outer layers are only weakly held together by gravity. Powerful stellar winds constantly blow enormous amounts of gas into space. In fact, these stars are slowly tearing themselves apart. They are nearing the end of their lives. And when they finally collapse, they may explode in some of the most powerful supernova events in the universe. You might wonder why stars can grow this large at all. But even more interesting is the fact that stars cannot grow infinitely large. Inside every star, two powerful forces are constantly fighting each other. Gravity pulls matter inward. Radiation pressure pushes outward. When nuclear reactions inside the core generate enormous amounts of energy, that energy pushes against the weight of the star. If a star becomes too massive or too large, the radiation pressure becomes so strong that it begins to blow away the star's outer layers. This creates a natural limit to how big stars can become. Astronomers believe that stars larger than about 2,000 times the Sun's radius become extremely unstable. Their outer layers drift away into space. Eventually, the star collapses under its own gravity. And when that happens, the result can be one of the most powerful explosions in the universe. When massive stars reach the end of their lives, their cores collapse in a fraction of a second. The outer layers of the star then rebound outward in a massive explosion known as a supernova. These explosions briefly outshine entire galaxies, but they also perform another crucial role in the universe. They create and scatter heavy elements across space. Iron, gold, carbon, oxygen. Many of the elements that make up planets, and even life itself, were forged inside the cores of giant stars and released during these explosions. In a sense, every planet and every living thing in the universe owes its existence to the death of ancient stars. The universe is filled with extraordinary objects, but few are as awe-inspiring as the largest stars ever discovered. These cosmic giants stretch across distances so vast that entire planetary systems could fit inside them. Yet despite their immense size, they are fragile. They exist on the edge of instability, constantly losing mass and slowly approaching their final moments. And when they finally explode, they will seed the galaxy with the raw materials for new stars, new planets, and perhaps new forms of life. Somewhere in the distant future, entire worlds may form from the ashes of these colossal stars, which means that, in a very real sense, the largest stars in the universe may also be the creators of future worlds.